Good morning, ladies and gentlemen. I wanted to take a minute and go over with you kind of graphing data, graphing equations, and then what the lines mean when we're talking about systems of equations. So I have a couple of examples here. This first one talks about a cell plan or a mobile plan. So $2.50 per gigabyte plus a $9 fee. That's at A+ Cellular. Thrifty Talk has a data plan that's $4 per gigabyte and no monthly fee. So we're going to look at these. We're going to talk about what the different items represent and then how many gigabytes is the point at which you should be looking at one plan or the other. Now it starts with what does X represent and what does Y represent. Now X and Y are dependent and independent variables. Okay, X is typically going to be right here. Okay, and I have it labeled. Anytime you make a graph, you want to label it. Okay, and every time the gigabytes change, the amount you're paying is changing. Okay, so that is Y. It's dependent on the number of gigabytes I use. If you think about our data usage, I think more about how many gigs I'm using than how many dollars I'm spending. If I know I'm supposed to stay below something, I count that by gigabytes, not necessarily, oh, I just spent $3 more. So X in this case is representing gigabytes, and I have it labeled here on the graph. The Y here is representing dollars or cost. Okay, and you will find that Y-axis represent cost a lot. That's a very common use for the Y-axis. So I want to go through and then graph these and look at the differences. Okay. Going to use kind of a red color for that one and kind of a green color for this one once I get them graphed. So let's take a look at A+ Cellular. It says that I have a $9 fee and $2.50 per gigabyte. Okay, that would also help me write an equation, but we're not going to do that right now. So I'm going to have to start at $9, which is right here. So I haven't used any gigabytes and I already spent $9. When I use 1 gigabyte, I spend $11.50, so almost $12. Okay, 2 gigabytes, exactly $14. And I like having a few that are exact. That makes it easier for my graphing. Okay, 4 gigabytes, $19. That's halfway there. Okay, so when I go through and graph this, which I said was going to be in red, I'm going to use a ruler real quickly because freehand graphing is not the most precise thing to do. And I'm going to show that that's that data plan. Okay. Now on the other data plan, I'm spending more money per gigabyte, $4 per gigabyte, but no monthly fee. So if I've used no gigabytes, I've also spent no dollars. If I've used 1 gigabyte, spent $4, 2 gigabytes, $8, 3 gigabytes, I'm now up to $12, 4 gigabytes, I'm now up to $16, 5 gigabytes, I'm up to $20, Okay. And I'm going to go ahead and mark this in green, just like I said I would. Okay. And you can see that right here, somewhere around approximately the $22 mark, these graphs are going to meet. So after how many gigabytes will they cost the same amount? Okay, that's going to be about $22. Now, you have other skills besides graphing. I could have written these equations, y equals 2.5, and I'll use G for gigabytes, plus 9, and y equals 4 times gigabytes, and there's no fee, so you don't need the plus 0. That is unnecessary. With that information, you could use substitution, elimination, any of your other tools to find out exactly how much it'll be when those meet up. And at some point, paying the fee is going to make it cheaper for a lot of gigabyte usage. If you don't use a lot of gigabytes, okay, then you're going to want to stick with a plan that doesn't have an initial fee. That's why we have these kinds of problems and these kinds of lessons. This is a real application. Now, on my next example, two people are reading the same book. They have already provided us with the graph in this one. Okay? Again, they ask us, what does X represent? What does Y represent? Well, here's your X-axis, and it's already labeled as minutes. Here's your Y-axis, and it's labeled as pages. This would be an interesting one for my son and I to do, because I read faster, but that doesn't mean I understand better. Now, I like that these are whole numbers. It's pretty well labeled. So let's talk about which one is Lucy. Okay, Lucy is marked right here. I'm going to make it a color. Lucy's going to get to be blue, just to make it easier for us to see. Okay, and Jake is going to get to be red, just to make it easier for us to see. Do that on your own pages as well. If it makes it easier for you, it's just a colored pencil or a crayon. So in this case, y is equal to, well, let's think about what we know. Y is equal to mx plus b. M is whatever the slope or the rate is going to be. B is your initial value or your starting point. Okay. So for Lucy, her starting point's way down here. I would call that 1. So something plus 1. What's her rate? Well, here she moved over 2 and went up from 1 to 5. So rise 5 over 2. Oh, 5 to x. So y equals 5 over 2, that's her slope, plus 1. Now I could also go from here and count up over this way, but again, I'm rising 5 spaces going over 2. Pay attention to the way it's numbered. Okay. For Jake's, okay, y equals, well, what's his rate? He goes from 4 to 6, he rises 2, and he takes 2 minutes to do that. He rises 2, and he takes 2 minutes to do that. So rise over run is 2 over 2. Where does Jake start? Jake starts at 4. So I'm going to clean this up a little bit. 2 over 2 is just 1. So Jake's equation is 1x, which is just x, plus 4. Okay, and then this says, after how many minutes will Jake and Lucy be on the same page? 1, 2. Okay, looks like just after or about 3 minutes. Again, with the actual equations, you could find out exactly how many minutes. Maybe it's 2.78 minutes or something. But just using the graph, about 3 minutes. Okay, and then the fact that Lucy started with less pages read, the fact that her slope, her speed is faster, she's going to pass Jake. Hopefully that makes sense and helps you with a really important skill that we're reviewing now.